Autophagy, the cellular process of self-cleaning and recycling, is emerging as one of the most critical mechanisms for maintaining brain health and preventing neurodegeneration. In the complex environment of the human brain, an organ with limited regenerative capacity, intense metabolic demands, and an accumulation of long-lived proteins, autophagy serves as the main line of defense against the buildup of damaged organelles, misfolded proteins, and toxic aggregates. When this cellular housekeeping function is impaired, the consequences can be devastating. A growing body of evidence strongly implicates disrupted autophagy in the pathogenesis of neurodegenerative diseases, particularly Alzheimer's and Parkinson's, making autophagy enhancement a promising target for both prevention and intervention. These observations suggest that maintaining robust autophagic activity in the brain may be essential for preventing or slowing neurodegeneration. Encouragingly, several nutritional compounds and lifestyle strategies show promise in enhancing autophagy specifically within neural tissue. One of the most powerful is docosahexaenoic acid, DHA, a long-chain omega-3 fatty acid abundant in the brain's gray matter. DHA supports neuronal membrane fluidity, synaptic plasticity, and mitochondrial health. More importantly, it activates autophagy-related signaling pathways, including SIRT1 and AMPK, while also suppressing inflammation, creating a cellular environment conducive to the safe removal of damaged proteins and the preservation of healthy neuronal function. DHA has been shown to promote autophagy in neurons, enhance the clearance of tau and amyloid aggregates, and support cognitive resilience with aging. Curcumin, the active compound in turmeric, also plays a notable role in neuroprotective autophagy. It crosses the blood-brain barrier and modulates several pathways involved in neuronal repair, including inhibition of the PI3K/ACT/mTOR axis, a key suppressor of autophagy. By reducing mTOR activity, curcumin encourages the activation of autophagic processes, which may help clear aggregated proteins and support mitochondrial turnover. Beyond its direct influence on autophagy, curcumin also acts as an antioxidant and anti-inflammatory agent, both of which are critical in preserving neuronal health. Animal studies have shown that curcumin supplementation can reduce beta-amyloid levels and improve memory in models of Alzheimer's disease. Magnesium L-threonate represents a particularly exciting nutrient in this context because it is one of the few magnesium forms that effectively crosses the blood-brain barrier. Magnesium is essential for enzymatic function, neurotransmission, and synaptic plasticity. In the context of autophagy, magnesium supports ADP production and AMPK activation, two processes foundational to initiating autophagic signaling. Research has shown that magnesium L-threonate not only raises magnesium levels in cerebrospinal fluid, but also enhances learning, memory, and synaptic density in aging animals. These effects likely stem from its capacity to promote mitochondrial health, support autophagy, and reduce neuroinflammation. Together, DHA, curcumin, and magnesium L-threonate form a synergistic trio that addresses multiple points of vulnerability in aging brain tissue. They support the production and signaling of autophagy-related genes, assist in the removal of neurotoxic aggregates, and foster an anti-inflammatory, neuroprotective environment. These nutrients can be obtained through a combination of dietary sources and supplementation. Fatty fish like salmon and sardines are rich in DHA. Turmeric, especially when combined with black pepper to enhance absorption, provides curcumin, and magnesium L-threonate is typically found in targeted nootropic supplements designed to improve cognitive performance. Enhancing autophagy in the brain is not just about nutrient intake, it is also influenced by lifestyle. Practices like intermittent fasting, aerobic exercise, and sleep optimization have all been shown to improve autophagic function in neural tissue. Fasting and exercise activate AMPK and inhibit mTOR, creating ideal conditions for autophagic cleanup. Deep sleep, particularly slow-wave sleep, facilitates the glymphatic clearance of waste products and may synchronize with peaks in neural autophagy, ensuring that the brain undergoes thorough nightly detoxification. In conclusion, autophagy is not a passive background process. It is a central pillar of brain health and a key to resisting neurodegenerative decline. When autophagy is robust, neurons are better equipped to maintain their internal environment, adapt to stress, and continue functioning well into advanced age. Nutrients like DHA, curcumin, and magnesium L-threonate offer practical and evidence-backed strategies for enhancing this process. Combined with a lifestyle that respects the rhythms of fasting, movement, and sleep, they represent a holistic approach to supporting brain longevity, protecting not just memory, but the very architecture of consciousness and identity.